everybody, welcome to another video on the Observe Intelligence channel. My name is Haas Bilyadi, and today we're gonna go through dealing with null values in pandas. So with that being said, let's get to work. Let's import pandas SPD, run this, and let's go ahead and import an Excel file, and basically this Excel file comes from, again, the machine learning guide for oil and gas using Python, and basically it has some 1 second frac data, and we're going to find the null values and see how many number of rows have null values in them, and do some data manipulation on that. So with that being said, let's go ahead and do pd.read Excel. The name of the Excel file is called Chapter 5 Imputation Dataset. It's from Chapter 5 of the book. Let's run this line of code. Let's go ahead and do df.head. And if I want to just visualize the first 7 rows of data, here we go. You got surface treating pressure, slurry rate, and proppant concentration. And just FYI, this data set has, if I do df.describe, has 4557 rows, 4721 rows of slurry rate, and 4752 rows of proppant concentration. So with that, let's go ahead and review a couple of useful functions. For example, one of them is called is null. So if I do df dot is null, like that, and if I run this, it's going to show me the first 5 rows of data and the last 5 rows of this data set or this data frame. And it's going to show me that, for example, since there are values available, for example, surface treating pressure, if you look at the first 5 rows, have values in them. And it says is null, so, and this is not null, so it's going to show false. So this is basically showing you can apply true or false to your entire data frame by just doing df.isNull. There's another useful function called not null. So df.not null, like that. And if you run this one, this is going to show that these are not null. These first 5 rows of data have data in them, and so they're not null. So that's why it says true, and basically it's going to assign true or false to each row of data based on if it's null or not null. So very, very handy function. So one useful thing that we can do with that, we can say df dot is null, like that, and then we can do dot sum. And what this does, it's going to give me the name of each of the columns that we have with surface treating pressure, slurry rate, and proppant concentration, and the number of null values in each of those columns. So for example, surface treating pressure has 195 rows of null values. Slurry rate has 31 rows of null values, and proppant concentration actually has 0 null values. So that's basically, it's a very useful function. We can actually do the same thing, and instead of is null, we can do not null, like that. If I run this, it's going to tell me that this many rows are not null. This many rows are not null for this column, and so on. So now, another thing that we can do is we can actually go to each column, say df, and then say df of, for example, surface treating pressure, which is the name of the column, dot is null. If I run this, it's going to show me the name of the rows, or in this case, row 206, 207, ... these are the rows that have null values within the surface treating pressure column. So you can see 206, 207. Again, if you export this into an Excel or CSV, you can see the entire data set. This is just within Jupyter Notebook that it just shows you dot, dot, dot. So you don't have to, so you can expand this out. Okay, so now that we understand this, let's go ahead and move on to dropping these NAs. What do I do to drop these NAs from my data frame? So let's go ahead and say df dot, there's a function called drop NA. Now within drop NA, we can define how. So if you actually hit shift tab while you're inside of the parentheses, shift tab, and expand this, you can see here, you can pass in some of these arguments, especially how is pretty important. And in place is also pretty important. In place is equal to true is going to make it stay in place permanently. Otherwise, the default is actually false. So if you don't make it in place is equal to true, it's not going to stay within that data frame. So with that being said, let's go ahead and actually pass in. So within how, if you scroll down, we can pass in any, or we can pass in all. So if any is passed in, it basically means if any NA values are present, drop that row or column. If all is passed in, if all values are NA, drop that row or column. So that's the difference between any versus all. So if any NA values are present, drop that row or column that belongs to any. All means if all values are NA, drop that row or column. So with that, let's go ahead and try this real quick. So let's go ahead and say df drop NA. How? I'm going to just say pass in any, okay? And if I do dot shape, for example, you can see here the original data frame had, if you scroll the way up, dot describe had 752. Then if you scroll down now, you see 4557. So I actually dropped all the NA values if any of the rows had NAs in them. You can actually copy and paste this, and again, change this to all, and run this. When you run this, so since not all of, if you look at the three columns that we have here for surface treating pressure, slurry rate, and proppant concentration, none of them have all NA values. So that's why you still have 4752 rows of data. So this is the difference between any and all. Another thing you can do, if you wanted to customize it even more, you can say df dot drop NA. Okay, drop NA. And you can pass in subsets. You can do subsets is equal to surface treating pressure. Let's just say surface treating pressure. Treating pressure. And let's also pass in slurry rate. Slurry rate, like that. And let's go ahead and say, comma, how I'm going to do any. Okay. And if you run this, it's going to just look at these two columns, okay, and drop the NA values in surface treating pressure and slurry rate. Okay, you can do the same thing, copy and paste this, and do, for example, all. You run this, see now the number changed. You had 4557, now you have 4728. 21. Now, these are not, if you want to make it in places equal to true, you can just add an in places equal to true. But we're not doing it for this exercise. I'm just trying to go through this and show you some of the optionalities that you have. So now, another thing that you can do that is very handy is looking at this kind of visually in a kind of a heat map and see what's missing in your entire data frame. And this is actually very useful. So to do that, let's go ahead and import matplotlib dot pyplot as plt. Let's go ahead and import Seaborn. We've covered these in previous videos. If you haven't watched those, please go back and watch those. Seaborn as SNS. Run these two. And let's go ahead and do plt.figure and do fig size. Fig size. I can do, for example, 10 by 8. Enter. And do sns.heatmap. And pass in df dot is null. Is null like that. And comma, and do y tick labels. Put that is equal to false, and also do c bar is equal to false, and pass in also the color map. C map is equal to Verdus. And run this. Now look at this. What we can see here, we can see surface treating pressure, slurry rate, proppant concentration, and the rows that are missing in this data set. So you can see in surface treating pressure, these rows are missing. In surface treating pressure and slurry rate, these two rows, these two are missing. And some of this data is missing here, and some of this data is missing here. So you kind of visually see, which one of the columns that you have miss the most number of rows. So in this case, surface treating pressure is missing the most amount of data in this case. So this is visually very helpful, and you can kind of dive into it immediately by when you start analyzing your data frame in pandas. So this is it for this video. Thank you very much for watching. If you found this video useful, feel free to like and subscribe to the YouTube channel for more free educational videos. And thank you so much.